So what we're gonna do is we're gonna start off with a quick warm-up. We're gonna be writing the formula and the name of the ionic compound that's gonna be made from the ions below. So we've been doing this for a while now, but I just wanted to make sure you guys got a good refresher of it before we get started with today's concept, because if you're having trouble with this now, it'll be really tough for you guys to get the concept that we're gonna go over today. So let's start with number one. So we have calcium's MCI. So for MCI, we have to go to the periodic table. Okay, calcium is right here. Okay, what's calcium's MCI? Anyone remember what calcium's MCI is? Yes. Yeah, +2. Sorry. Can you go to Chromebook and sign off the campus and then just take a seat somewhere in the back? I'll let you know. All right, yeah, calcium is gonna be +2. Okay. Okay, so for calcium's MCI, we're gonna write calcium +2. There's a stool over there if you want to just grab it. I'll get to you in just a sec. Okay, and then for hydroxide, okay, what we're gonna do is we're gonna go to the polyatomic chart. So you're gonna have to look in your sheet protector. So what do you guys have for hydroxide? Yeah, it's me. It's OH minus. It's O, and it's a little bit negative, so it's exactly like me. Okay, so we're gonna write OH minus. Okay, so that's hydroxide. All right, so we have calcium's MCI and hydroxide, and we're gonna put them together. So obviously we need more hydroxide, right? So how many hydroxides do we need in total? 2, yeah, because we need to balance out the +2 and the -1, okay? So we're gonna put them together, so we just write them next to each other, so calcium and hydroxide. Since I used 2 hydroxides, I just put a 2, and then there you go. That's gonna be your formula. Okay, I done. All right, now we need to name it. So for the name, very simple. We just take the cation. The name doesn't change, so this is calcium, so we're just gonna write calcium. And then for hydroxide, we just need to figure out if the anion is polyatomic or if it's one element. So since we got it from the polyatomic chart, it's gonna be polyatomic, and if it's polyatomic, they keep their name, so we don't need to change it at all. So the name for this compound is going to be calcium hydroxide. Okay, and that's it. This is the name. All right, any questions about that? Okay, so I'll give you guys about a minute and a half to work with the person next to you on number 2. We have gold 4 nitride. I want you guys to write just the formula for this one since you have the name already. Okay, so find the formula for gold 4 nitride. You can work with the person next to you, and then we'll go over it together before we start the concept for today. So take about a minute and a half to try that out. Alrighty, guys. So let's go over number 2, and then we will move on to the new topic for today. Okay. So gold for nitride. So what did you guys get for gold's symbol? Yeah, AU. Gold is AU. Now, if you guys notice, it has a 4 behind it. So that means gold's charge is +4. Okay. So gold is AU on the periodic table. The charge is 4, so we put +4. Now, if you guys take a look here at the anion, it's nitride. Now, nitride sounds kind of like nitrites, but it's not a polyatomic ion, because if you go to the chart for nitrites, it's NO2, but it's different from IDE. Instead, we have to look at this rule. Anions that are made of one element have their ending replaced by IDE. So if we go to the periodic table and we look for one that kind of sounds similar to nitride, you should have gotten nitrogen. Okay, so this is going to be nitrogen's ion. So we're going to write nitrogen. Okay, and then for nitrogen's MCI, it's going to be -3. All right, so the balancing for this kind of got a little bit annoying, but hopefully you guys figured it out. So right now, is there more positive energy or negative energy? There's more positive, right? It's 4. So what we have to do is we have to add a negative, but now it's -6. So there's too much negative energy. So we have to add another gold 4, but now it's 8. So it's more more positive energy. So we got to add another nitrogen, but now it's -12. So it's too much negative energy. And so what we're going to do is we're going to have to add another one. That'll get us to 4, 8, 12. And then it's -9. So if we add one more nitrogen, that'll get us to +12 and -12. So the balancing for this one got a little bit annoying, but hopefully you guys were able to figure that out. And so the amount of gold ions we need is 3. And then we have 1, 2, 3, 4. So we have 4 nitrogens. Okay, any questions about how we got that? I know it's a little bit tricky, but again, we're not going to be counting very high in this unit. So just keep adding until they balance out. Okay, so for the formula, we have 3 of these guys. So we put AU3. We use 4 nitrogen, so it's going to be N4. And there is your formula. Okay. All righty. Any questions? Okay. All right. So while you guys are finish copying that down, we have a new handout. This is kind of going to replace the one in the sheet protector. So the side that has the new handout, the one with the common polyatomic ion, I want you guys to just put it in the sheet protector in front of it. So there's a new table on the bottom. So we're not going to have the naming rules there. That kind of got to get down. But this is the handout that you're going to be having on your test. Just make sure that you guys take one, pass it down. If you put it in the sheet protector in front of the common polyatomic ions one, I would appreciate that, because that is what we are going to be using for today. So if you guys have like 2 sheet protectors in front of you, just put it in both of them for me, please. But that's the one that we are going to be looking at. Okay, so on that one, you should have your common polyatomic ion. I'll pick up the extras. And you should also have this one right here, solubility table. That's the one that we are going to be looking at today. Yeah. All right, so on one side, you should have a periodic table, and the other side, you should have the handout I just gave you, okay? So one side periodic table, one side the new handout. Okay, and if you want a physical copy for yourself later, they'll be up here so you guys can pick it up. But that's what we're going to be looking at. If you guys notice, the lecture for today is called Solubility and Precipitation. And so this is the table that we're going to be referring to. It's called the solubility table. There's a lot of stuff on it, but we're going to go through it step by step. That way you guys have a good understanding of it. All right, let's move on to the notes for today. Okay, so I'll tell you guys what you guys have to write down and what you guys don't have to write down. Again, this is recorded and you're going to have these notes available for you. So today the main topic is solubility, but don't write this down, okay? Solubility just describes a compound or molecule's ability to dissolve in water. Okay, so this is the one that you do want to write down, these ones, soluble and insoluble. So if a compound or a molecule is soluble, that means it can dissolve in water. And if it's insoluble, it means it cannot or does not dissolve in water. Okay, so if a compound is soluble, it can dissolve in water. And if it is insoluble, it means that it cannot dissolve in water. Okay. Okay, so you guys might be familiar with this already. One thing that's soluble in water is like salt. If you guys put salt in water, you're able to dissolve it. Something that's insoluble would be like oil. If you put oil in water, that doesn't dissolve in water, right? It just kind of stays separate from the water. That would be example of something that's insoluble. Okay, and so that's the difference. So we're going to be looking at how different solutions, different liquids containing molecules, how they can be soluble or insoluble. And that table that I just passed out, that's going to help us determine that. Now, if a compound is insoluble, if a molecule does not dissolve in water, it forms something called a precipitate. Okay, and a precipitate is a solid that forms in a liquid. And so different ways you can tell if a precipitate has been created is if there's some kind of cloudiness that forms, if you see gunk or chunks, or some kind of color appear out of nowhere, that is indication that there is a precipitate that was formed. Okay. Okay, and I'm going to show you guys what that looks like right up here. Okay, so I'll give you guys a second to copy that down. But just know that if something is soluble, it does dissolve in water. If it is insoluble, it does not dissolve. And so if it's insoluble, you're going to see a precipitate being made. And so a precipitate is a solid that forms inside a liquid. Okay? And you can tell because you'll see some type of cloudiness, see some type of gunk, chunks forming, or some kind of color change happen out of nowhere. Okay. All right, so up here I have two different solutions, two different liquids, right? And they're both clear, right? It's both kind of clear. But what happens is, so they're both soluble. They both contain a compound that's soluble. But what happens is, if I pour one of them into the other, all of a sudden, you're going to see a random color change, right? And so the color change tells us that even though they were soluble together, when you mix them together, it forms a precipitate. So you saw some kind of color change. So that tells you that the thing that was formed in here when you mix them together is insoluble. Okay, does that make sense? So that's how you can tell if a precipitate was formed. If you have two liquids that are completely clear, you mix them together and all of a sudden it's a different color, that tells you that it formed a precipitate. And that's what we're going to be doing in the next lab. I'm going to be giving you a bunch of different chemical solutions. You're going to be mixing them together and seeing if they form some type of precipitate. Okay, and with that table that I just passed out, the solubility table down here, we're able to predict before mixing them whether or not a precipitate is going to form. Okay, so that's what we're going to be doing today. We're going to be learning how to predict whether or not mixing two solutions will make a precipitate. All right, any questions? All right, let's get into the problem. I'm going to teach you guys how to read the solubility table first. Okay, so let's all look at this table. Okay. So on this table, if you guys notice on the top, we have these positive cations, and then on the left side, we have the anions. And in the middle, we have these, I guess, terms that tell you, that say if it's soluble or insoluble or slightly soluble, okay? So what you want to do to predict whether or not something is going to be soluble or not is you just need to figure out the cation and the anion that makes it up. So let's say, for example, we were mixing Na plus, and we were mixing that with OH minus, okay? So if we combined NH plus and OH minus, we are able to predict whether or not it's going to dissolve in water. So what do you guys think? Just based on the two, does it dissolve in water? Yeah, it's soluble, so it's going to dissolve in water. That's pretty much how you read it. It's very simple. Okay, so let me give you guys another example to try out before we move on. Okay, what if we mix iron 3 and we mix it with sulfide? Is that going to be soluble or insoluble? Yeah, insoluble. It's not going to dissolve in water. So if you mix these two together, you'll see these chunks forming inside the liquid, or maybe a color change like what we saw up here. Okay, so basically, if it's soluble, it means that there is no precipitate. If it's insoluble, that means it's going to form some type of precipitate. If it's slightly soluble, like this one right here, this one is still going to form a precipitate. Okay, so very easy to read the table, not too difficult. Okay, all right, let's do a couple practice problems, and then I'll get you guys started on the assignment. Now, it's not going to be that easy. I'm never going to give you just the positive and just the negative. Okay, I want to make your lives a little bit more difficult than that. Okay, because that's not how it works in the lab, and I want to make sure you guys are scholars prepared for chemistry. Yeah. You don't need to draw the chart. You don't need to write the steps because, again, this is all on Canvas for you. So if you need to look back at the steps, you can look back, and I'm recording this. So if you guys need a review, you can. Just solve the problem out with me, okay? All right, so a typical problem that you'll see is this. You're going to be mixing one ionic compound with another ionic compound, okay? And you need to figure out, is it gonna form a precipitate, okay? So let's go through this step by step. Step one is you wanna figure out which ions the compound will break into, okay? So I'm gonna do the first one for you, and then I'll have you guys try the second one. So let's take a look at ZnCl2, okay? We need to figure out what the cation is and what the anion is. So what the positive one is and what the negative one is, okay? An easy way to do this, guys, by the way, is you guys can look at this chart and it'll kind of tell you what the cation and anion are, okay? So let's look at ZnCl2. So which one of these is the cation? Yeah, Zn. Okay, because it comes in the front, right? We always put the positive one at the front. Also, if you guys look at the table right here, Zn, and what's the charge on Zn? 2+, yeah. Okay, so we're gonna have 2+. Okay, and we can also verify that because the anion has to be chlorine, Cl, and chlorine's MCI is -1, and it takes 2 of them to balance out the Zn. Okay, so pretty simple. Okay, so I want you guys to take maybe 30 seconds. I'll give you a minute. I'll give you guys a minute to try this one out. I want you to figure out what the positive and negative ions are inside FeNO3. Okay, so take a minute to try that. You can work with the person next to you, and then we'll, and then we'll go over it together. Alrighty, guys, let's go through this together. So let's start with the cation. What did you guys get for the positive ion here? Yeah, Fe, and what did you guys get for the charge? Yeah, 3+. Okay, and then for the anion, we have NO3, and the charge is minus because that's nitrate. Good. Okay, and you guys could have gotten that either by looking at this chart, the polyatomic chart. You see nitrate, that's NO3 minus. Or you could have gone to the solubility table and you'll see that NO3 is minus and Fe over here is 3 plus. Okay, so there's different ways for you guys to find out the same answer, but that's how we do step 1. Okay. Okay, next thing we're gonna do is we're gonna determine the new potential ionic compound. Okay, so what that means is, if you guys notice, we started with ZnCl and FeNO3, right? But if you mix them together, they can make new ionic compounds. And so the new ones that they can make, we just kind of mix and match the positive from one of them and the negative with the other. So Zn2 plus can react with the NO3 minus from this guy. So if we put them together, we're gonna make ZnNO3 2. Okay, because if the Zn from this guy, the first one right here, mixes with the NO3 from this one, you would need 2 NO3s to balance out the Zn, right? So that's all we're doing. We're just trying to figure out what they can make if we mix the two together. That's why I wrote cross multiply, because we're not really multiplying anything, but you kind of just go across. You just get the positive from one of them and the negative from the other one, and you put them together. Okay. All right, so that's the first one. I want you guys to write the second one now. I want you guys to write the other new potential ionic compound that can be made. Okay, so take about 45 seconds. You can work with the person next to you and just try to figure out what the new ionic compound that you can make is. All right, guys, let's go through it together. Hopefully this wasn't too bad. So we're just gonna take the Fe3 plus, and then we're gonna combine it with Cl minus. So obviously we're gonna need more chlorines. So how many chlorines do I need in total? 3. Good. So I would just write FeCl3. So these are the 2 new potential ionic compounds. All right. So that's step 2. Not too bad. All right, so what we're gonna do now is we're gonna see if these guys are gonna form a precipitate. So what we're gonna do is we're gonna move down to step 3, okay, and we're gonna determine if the new and old, or the old and new compounds are soluble. Okay, so I have the new ones written here, and we also are gonna look at the old ones. Okay, so I'm gonna write the old ones up here real quick. So the old one was ZnCl2. And then FeNO3. Okay, so these were the old ones. Okay, and these are the new ones. And we're just gonna figure out if they are soluble or insoluble. Okay, so I want you guys to pull up that chart again. Okay, the solubility table, this one right here. Okay, and what we're gonna do is we're gonna look at every single one of these and figure out, is it soluble or is it insoluble? So let's start with the first one, ZnCl2. So what we're going to do is we're going to go to the table and look for Zn. Zn is right here. Okay, zinc. And if we mix it with Cl, is it going to be soluble or insoluble? Yeah, soluble. Zn is right here. Cl is right here. They meet and it's soluble. So what we're going to do is we're just going to write that ZnCl2 is going to be soluble. Okay, so what I want you guys to do now is go through the other three compounds, this one, and this one, and I want you guys to write down if it's soluble or insoluble. Okay, so same thing we just did. Go to the table and then use the cation and anion, and I want you guys to figure out if it's soluble or insoluble. I'll give you guys about 45 seconds to do that, and then after that, we'll go to step 4, which is the last step of this problem. Ichi, can you go to the printer real quick for me? Yeah, thank you. Alrighty, so what you guys should be doing is using the solubility table in order to figure out if all of these three compounds are soluble or insoluble. All right, let's go over them. So let's start with FeNO3 3. Okay, so if we go to the solubility table, we look at Fe and we go down to NO3. Is it soluble or insoluble? Yeah, it's going to be soluble because if we mix Fe and NO3, it's going to be soluble. So we're going to write down that it is soluble. What about ZnNO3? Yeah, this one is also soluble because if we go to the chart, we look for zinc, wrong chart. We go to zinc and we go to nitrate, it's going to be soluble. Okay. And then for the very last one, FeCl3, if we go to the table and we look at Fe and Cl, is it soluble or insoluble? Soluble. So every single one of these guys is going to be soluble. Thank you, G. Okay. Okay, so if they're all soluble, are they going to form a precipitate or not? No, right? No precipitate, because if everything dissolves in water, it's not going to form any chunks. It's not going to change the color. It's just going to stay the same way. So that's going to be for part 4. For part 4, we're just going to write no precipitate, or I just like to write NP, no problem. Okay, so NP, no precipitate. Okay, so for part 4, we just need to write no precipitate. And the reason why is because every single one dissolves in water, so there's going to be no precipitate formed. Okay, but let's just say hypothetically that this one right here was insoluble. Hypothetically, okay? That means that the precipitate that is formed is going to be FeCl3 is the precipitate, hypothetically, but we know that it's actually soluble. So whatever is insoluble or whatever is slightly soluble, that's what you're going to be writing down as the precipitate. Okay, but in this situation, there's no precipitate because they all dissolve in water. Okay, make sense? You guys think you could do this on your own? All right, we'll do one last problem similar to what you'll see on your assignment today, and then I'll get you guys started. So on your assignment today and on the lab, you're going to get a table like this. And you're going to be using this table to predict whether or not mixing these chemicals are going to form a precipitate or not. So I'm going to go over how to solve this table and make sure you guys are following along and let me know if you guys have any questions, because this is going to be how you do your lab. And for your lab, it's going to be a lot bigger than this table right here. Okay. Okay, so let's go through step by step. So the first thing you want to do is you want to go and look at all the compounds that you're mixing. So this box is going to represent when you mix this one, and then this box is going to be when you mix this one, and so on and so forth. So the first thing you want to do is you want to look at every single molecule and figure out what the cation and what the anion is. So for this one right here, I'll do the first one for you, and I'll have you guys try the other one. The cation is going to be Zn 2+. And the anion is going to be SO4 2-. So SO4 2-. Okay, and so you need to go through every single one of these molecules and figure out what they break down into. What is the cation and what is the anion? Okay, so I'll give you guys 2 minutes. I want you guys to do the same thing we did here for FeBr3, K3PO4, and PbNO3 too. Okay, so use your solubility table. This table that I gave you today will help you a lot in figuring out the cation and anion. Okay, so take 2 minutes. I want you to do what we did for this one for every single one of the molecules on the table. Okay, and then we'll come back together and move on. All right, I'll give you guys 30 more seconds to finish up. All righty, guys. Let's go through the table and break everything apart. So for Fe, you should have gotten Fe3 plus. For Br, you should have gotten Br minus. For K, you should have gotten K plus. For PO4, you should have gotten PO4 3 minus. For PB, you should have gotten 2 plus. And then for NO3, you should have gotten -1. Okay. So I got all of these just by looking at the solubility table. So just make sure that you guys refer back to it. God bless you. All right. Any questions? This part pretty easy? Kinda. Yeah, just look for the cation and the anion on the table, the solubility table, and it'll give you the charge. Easy way to check it. Okay, so what we're gonna do now is we're gonna figure out if the compounds, can you stop flipping that, please? Thank you. Okay, so what we're gonna do now is we're gonna be mixing these together, and then we're gonna be seeing if a precipitate is formed, okay? So what I'm gonna do is I'm gonna take the positive of one of them and the negative of the other one, and I'm gonna be checking if they make a precipitate or not. Okay, so I want you guys to look at zinc and PO4 on the solubility table, okay? We're going to look at zinc and PO4. So if I look at zinc and PO4, is it soluble or insoluble? Yeah, it's insoluble. So that means when you put those together, it's going to make an insoluble compound. So we're going to write zinc, PO4, and you do need to balance this out because it's going to be opposite charges, but I'll do it for you here. It should be Zn3, PO4, 2, and that's going to be insoluble. So that's your precipitate. Okay. Next, you're going to look at the other one. So you have K plus and SO4 2 minus. Take a look at the chart and then tell me, are these two soluble or insoluble when you mix them together? K plus and SO4. Yeah, this one is soluble. So these two are not going to form a precipitate. So that means that the only precipitate that's formed in this reaction between K3PO4 and ZnSO4 is going to be this guy. This guy is the precipitate. Okay. So that's pretty much how you fill out this table. All you need to do is take the positive of one of them the negative of the other one and figure out if it's going to be soluble or not. Okay, so I know this is kind of weird, a little bit tricky. We're using a lot of different concepts at the same time. So I'll go through one more of the examples for you guys. And then after that, I'll have you guys fill out the other ones. And then I'll get you guys started on the assignment. Okay. So here we have F3 plus and we have PO43 minus. So what we're going to do is we're going to go to the chart and look at what happens when you mix them together. Okay, so if we have Fe3 plus and PO43 minus, is it going to be soluble or insoluble? Yeah, it's insoluble when you mix them together. So we can go back to the table and we can say that, hey, when I put Fe and PO4 together and they balance out so you don't need to put any numbers, they're going to be insoluble. So this one is a precipitate as well. Okay, but the other two ions that we can mix, K plus and Br minus, if we look at them on the solubility table, what happens if we mix them? Is it soluble or insoluble? Soluble. Yeah, that one's soluble, so there's no precipitate between those two. Okay, so that's pretty much all we're doing. This table just tells us if we mix them together, if it makes a precipitate or not, and also the identity of that precipitate. All right, do you guys think you can try the other two boxes? Maybe. All right, well, I'll give you guys 5 minutes, not 5 minutes, 3 minutes to try that out. See if you guys can get it. If you guys get it incorrect, it's okay. We're still learning this and we'll have a day where we just focus on practicing this. But I'll give you guys 3 minutes to try that out. Work with the people around you to get the answer. You guys can check your answers with them. After that, we'll go over it and then I'll get you guys started on your assignment, okay? Take 3 minutes, try that out. Alrighty, guys, just another minute to finish up, and then we'll go over it together. Huh? A flip phone? Yeah, dude. I'm an old man. Nah. Yeah, you fold it. And if you're mad, you fold it real hard. See, you guys don't have the benefit of doing that with the smartphone. Yeah, because you're gonna damage your phone. But yo, those old Nokias were indestructible. Yeah, dude, legit dropped it off a second, like the second story, and it was fine. Just put the battery back in, you're good to go. Did I have what? Pac-Man? No. Oh, I didn't play Pac-Man. That's older than me. My first video game was Yoshi's Island on the Super Nintendo. Yeah. Dang. I'm like really aging myself. Yeah, I was there when Pokemon first came out. Dude, that was like the biggest thing. We would take our Game Boys to like school and we would play in the bathroom. Dude, with the link cable, you had the wire connecting them. Dude, good memories. All right, let's go over this and then I'll get you guys started on the assignment. So in this box, we're gonna be combining ZnSO4 and PbNO3 too. So we're gonna be mixing the cation from one with the anion from the other. So if I mix Zn and NO3, does it form a precipitate? No, right? If you go to the chart, we're gonna look at Zn and NO3. Zn, NO3, it's gonna be soluble. So it's gonna be no precipitate on that one. So if I mix them together, it would form this technically, but since it is soluble, it is not a precipitate. Okay, now let's look at Pb and SO4. So if we go to the table and look at Pb and SO4, is it gonna form a precipitate? Yes, it's insoluble. I know this thing is covering it, but Pb and SO4 is gonna be insoluble. So that one is going to form a precipitate. Okay, so if we put them together, Pb and SO4 balance each other out, and that's going to be insoluble. So this guy right here is going to be our precipitate. All right, and then last but not least, we have FeBr3 and PbNO3. So if we look at Fe and NO3, that is going to form no precipitate. Oops. Okay, so if we put Fe and NO3, it should be soluble. Okay, and then last but not least, we have Pb and Br. If we mix Pb and Br, is that going to form a precipitate? No, right? If we go to the table, we look at Pb, again, it's blocking it. Pb and Br, it's going to be soluble. So this is the only one out of all these combinations that's going to form no precipitate. Since they're both soluble, you would just write NP in that box to show no precipitate. Okay? And that's pretty much it. Again, this is what you're going to see on your exam, and this is what you're also going to see in the lab. So make sure you guys get good at doing these tables because basically your entire Unit 2 grade is going to come from your ability to figure out these tables and answer it correctly. Yeah, what's up?
What's the end of the quarter?
The quarter, good question. The end of the quarter is, I don't know, I'll get back to you. I just got an email about that too. But I'll get back to you on that. All right, other than that, I'll give you guys the rest of the class period to work on this assignment, and then let me know if you guys have any questions.